Everything you have ever heard about mechanics ripping you off, about dealer service writers inventing repairs, about upsells on tires that still have tread, about diagnostic charges that turn into $800 bills. Almost all of it is true. AAA tracks consumer complaints. The Better Business Bureau tracks unresolved disputes. The auto repair category has been in the top 10 complaint sectors for 30 years running. There is a real reason most DIY car content on YouTube exists. The audience for "Do not let them charge you for this" has every right to exist. And if you are watching this channel, chances are you belong to it. But there are 7 specific repairs where the entire anti-mechanic narrative falls apart. 7 situations where what looks like overpricing is actually the shop absorbing equipment costs, legal liability, and decades of accumulated training that the home garage cannot match. 7 repairs where doing it yourself costs 3 times what the mechanic charges, sometimes 10 times what the mechanic charges, and a few where doing it yourself can injure or kill you outright. This video is uncomfortable to make. If the channel's normal mode is, "Here is what mechanics overcharge for," this is the inverse. The 7 exceptions. The cases where the mechanic is right at 100%. Where the $400 bill is not a ripoff, but a discount. Where saving $300 on labor means risking $5,000 of damage, or your insurance liability, or your life. Specifically, the 7 are: timing chain replacement, modern air conditioning service, continuously variable transmission internal work, 4-wheel alignment, supplemental restraint system service, engine control unit programming, and high-voltage battery work on hybrids and EVs. Each one fails the DIY test for a different reason. Some require specialized tools that cost more than the car. Some require legal certification before you can even buy the consumables. Some require knowing failure modes that take years to recognize. And one involves voltages that will stop your heart in under 2 seconds if you make one wrong move. I have personally tried to DIY my way through 3 of these 7 over the last 15 years. I learned each of them the hard way. Once on my own 2006 Civic, once on a customer's truck, and once on a hybrid that should not have been touched without certification. I will tell you which 3 and what each one cost me, in dollars, in time, and in the worst case, in a car that should not have ended up in the salvage yard, but did. This is the inverse of the channel, and it is the most honest video I think I will ever make. Before getting into case 1, the framing matters. The argument is not trust your mechanic on everything. The argument is also not DIY is wrong. So what is it? The argument is that control, which is what most owners watching this channel are actually after, does not mean doing every repair yourself. Control means knowing the boundary, knowing what is yours and what is not. The most expensive mistake I have ever made on a car was not laziness. It was confidence about something I should have left alone. And if you have been working on your own cars for any length of time, you already know which one of yours that was. The 7 cases below all share one pattern. In each one, the cost of getting it wrong is at least 3 times higher than the cost of paying the shop in the first place. Sometimes it is 10 times higher. The math is not subtle. The reason it is not subtle is that each of these repairs sits in a category where the mechanic is not selling you labor. The mechanic is selling you access to a piece of equipment, a license, a certification, a procedure manual, or a body of failure mode knowledge that the home garage simply cannot replicate. If a repair requires a $25,000 piece of equipment, the labor charge is not for 40 minutes of work. The labor charge is for amortizing the equipment over thousands of jobs. Same with a license. When a refrigerant service requires a federally certified handler, the labor charge includes the $400 exam, recertification cycle, and the legal exposure if anything goes wrong. The shop is not overcharging. The shop is pricing a real expense into the bill. Case 1. Timing chain replacement. Modern engines, almost everything since 2005, have moved away from timing belts toward timing chains. Manufacturers will tell you the chain is lifetime. That is marketing. In reality, the chain stretches predictably between 120,000 and 200,000 miles, depending on driving style, oil change interval, and engine design. When it stretches beyond spec, the camshaft timing drifts. Performance drops. Fuel economy drops. Eventually, the chain skips a tooth, the valves meet the pistons, and the engine is finished. The DIY path on this looks deceptively simple. There are videos showing chain replacement on a 2012 Ford EcoBoost in under 3 hours. The videos are real. The videos are also misleading. What they do not show is that on a modern transverse-mounted 4-cylinder, you typically have to drop the engine subframe, or remove the engine mount on the timing chain side, or pull the entire valve cover assembly with the cam carrier intact. You have to align 3 camshafts to within 1 tooth of spec. You have to torque the tensioner bolt to a precise value while holding the chain in position. And you have to do all of that without rotating the crankshaft, because if the crank rotates while the chain is off, the valves drop into the cylinder. Take a 2015 Volkswagen Tiguan 2-liter turbo. The factory service procedure for chain replacement runs to 47 pages. The required cam holding tool is a Volkswagen-specific special, costs about $600 from a tool supplier, and is not interchangeable with any other brand. Without the tool, the cams will rotate under spring pressure the moment the chain is off. If the cams rotate even slightly, the timing is gone. If the timing is wrong by 1 tooth and you start the engine, the valves bend. The repair becomes a complete top-end rebuild, $4,000 minimum, sometimes $7,000 or $8,000, depending on the head's condition. A specialty shop with that exact cam tool will do the same job in 7 to 9 hours of labor, with a high probability of success. The labor cost is between $900 and $1,400 at typical shop rates. The total bill, including chain, gaskets, and tensioners, runs between $1,600 and $2,300. The DIY cost, if it goes wrong, is between $4,800 and $7,500, and a car that does not run while the parts come in. Honest answer is, this is not a labor savings question. Is the $600 cam tool sitting in your toolbox? Most owners do not own one. The shop bill is the discount. Case 2. Modern air conditioning service. This is where a regulatory requirement makes DIY essentially illegal, and most owners do not know it. The EPA Section 609 Technician Certification has been required since the early 1990s to purchase, handle, or service automotive refrigerants in containers larger than 2 pounds. The certification involves a written exam, a small fee, and a renewable credential. Without it, you cannot buy R134A in commercial quantities. You cannot buy R1234YF in any quantity. You cannot legally vent old refrigerant to the atmosphere. The parts store small cans of R134A. Those exist for hobbyist use. But they only work on the older R134A systems, which means cars from before about 2017. Almost every new car sold today uses R1234YF, which is mildly flammable, costs about $100 per pound at the consumer level, and absolutely requires a recovery machine to service. You cannot just vent it. You cannot just top it up. The system needs vacuum down to 29 inches of mercury, then a metered fill that matches factory spec to within 1/10 of a pound. The shop is buying a $15,000 refrigerant recovery and recharge machine. The shop is paying recertification fees on it every year. The shop is paying for the EPA Section 609 license for each tech. When the AC repair bill comes back at $600 for a system service plus seal kit, that is not overcharging. That is the only legal path that exists for that work on a car newer than 2017. Take a 2020 Honda CR-V hybrid with a weak AC system at 65,000 miles. The shop quote was $480 for diagnostic, leak check, dye trace, system evacuation, and recharge with R1234YF. The owner thought it was high. The actual cost breakdown, $50 for the dye and seal conditioner, about $90 worth of refrigerant, 3 hours of skilled labor at $120 per hour, and the amortized cost of the certified handling. The labor margin is reasonable. The DIY alternative is to vent the system illegally, risking EPA fines that can run into tens of thousands per violation, plus replacing parts you cannot legally access. Case 3. Continuously variable transmission internal work. CVTs use a steel belt or chain running between two variable diameter pulleys. The pulley faces are precision machined to within a couple of micrometers. The shimming of those pulleys, the small spacers that determine pulley angle and belt clamping force, has to be set within tolerances measured in hundredths of a millimeter. JATCO, which builds most Nissan and Subaru CVTs, publishes shimming tolerances to roughly 5 micrometers. 5 micrometers is about 1/10 the diameter of a human hair. A CVT internal repair is not really a repair. It is a precision rebuild. The pulleys come out, the shimming is measured, the belt is inspected, the valve body is rebuilt or replaced, and the case is reassembled with new gaskets and seals, torqued in a specific sequence to a specific pattern. The job takes a specialty CVT shop somewhere between 12 and 20 hours. The tools include hydraulic test gauges, a specialty pulley alignment fixture, and a thermal control bath because the shim measurement changes with temperature. A 2017 Nissan Altima with a CVT that started shuddering at 72,000 miles, a real case from the shop floor, came in for a quote. The dealer wanted $4,800 for a new CVT from Nissan. An independent CVT specialist wanted $2,300 for a complete rebuild, including new belt and updated valve body. The DIY option, which the owner considered, would have meant buying a used CVT from a salvage yard for $900 and swapping it in over a weekend. The owner went the salvage route. The swapped CVT lasted about 6,000 miles before the new one started shuddering the exact same way. 2 CVTs failed. Total cost, $3,000 in parts, plus the original $2,300 for the eventual professional rebuild. About $5,300 to do what would have been $2,300 if done once correctly. The salvage CVT shuddered because the wear pattern was identical to the original. They both came from the same model year with the same software calibration issue, which got fixed in a later software update. Look at the failure mode, not the symptom. A used part with the same fundamental defect is not a solution. Quick note before Case 4. If any of these are saving you a misadventure, the easiest thing you can do to send some back this way is hit the subscribe button. It costs nothing, takes 2 seconds, and tells YouTube to keep this kind of breakdown in your feed. Case 4 is where the equipment cost stops being a metaphor and starts being a physical machine that costs more than the cars most owners drive. Case 4. Four-wheel alignment. This is the case where the equipment argument becomes most concrete. Modern alignment requires a Hunter Engineering HawkEye Elite system or equivalent equipment from John Bean or Ranger. The HawkEye uses high-resolution cameras mounted on rotating targets that clamp to each wheel. It measures camber, caster, toe, thrust angle, setback, and individual wheel offset to within 1/100th of a degree. The system costs between $40,000 and $90,000, depending on configuration. Plus the lift, the runway, and the calibration block that goes with it. Just the calibration block, the steel reference that the system uses to zero itself, costs around $4,000. There is no DIY alignment that comes close to this accuracy. The string method, the toe plate method, the digital level method, all of these can get camber and toe to within about half a degree if you are very careful. That is 50 times the tolerance of a HawkEye system. On modern cars with electric power steering and stability control, that level of imprecision puts the car outside the tolerance window where the steering computer can compensate for it. Within a few thousand miles, tire wear becomes asymmetric. The car starts to pull. The steering ratio feels off. Sometimes the stability control intervenes when it should not. A four-wheel alignment at a shop with the Hunter rig runs between $150 and $250, including a tire pressure check. The shop is amortizing a $60,000 machine across maybe 2,000 alignments per year. The labor itself is 45 minutes once everything is mounted. The DIY alternative is $200 worth of jigs that get you to a half-degree tolerance, which gets you replaced tires in 9 months instead of 40. If you have ever burned through a set of decent tires in under a year and could not figure out why, this is one of the candidates. The math is not subtle on this one either. Case 5. Supplemental Restraint System Service. This is the legal liability case. SRS, airbags, seatbelt pretensioners, side curtains, knee airbags. Uses pyrotechnic charges to deploy in about 30 milliseconds, with deployment forces measured in hundreds of pounds. The pretensioner alone uses roughly 240 pounds of force to retract the seatbelt in the first 8 milliseconds of a crash. The driver's airbag deploys with about 400 pounds of force from a folded position against the steering wheel. Working on SRS components without certification creates 2 distinct problems. Problem 1 is the deployment risk. A pyrotechnic charge that deploys outside the car during service, when somebody is leaning over the steering wheel, removing the clock spring, for example, can break a nose, knock teeth out, or detach a retina. The shop has procedures and tools for safe handling. The home garage typically does not. Problem 2 is insurance liability. If the airbag system has been serviced outside of a certified shop and the car is later in a collision where the airbag fails to deploy or deploys incorrectly, the insurance company can void the claim. The driver becomes liable for the medical costs of all occupants. On a car with 3 occupants in a moderate collision, that liability can run to $200,000 or more. A shop service on an SRS module, clock spring replacement, sensor recalibration, deployment test, runs between $300 and $700 depending on the car. The total liability avoided is in the hundreds of thousands. There is no plausible DIY case here. I learned this one watching a friend remove a steering wheel from a 2004 Accord. Clock spring not disabled, airbag connector still live, nothing deployed. We were lucky. The shop charge for the same job that afternoon would have been about $380. Ask yourself, is your face worth that? Case 6. Engine Control Unit Programming. This one has changed dramatically in the last 15 years. Older ECUs, through about 2010, could be reflashed by hobbyists with affordable bench programmers. Modern ECUs are different. They use proprietary cryptographic keys, often called seed keys, that change between manufacturers and between model years within the same manufacturer. To program a modern ECU, you need 3 things. The first is dealer-level diagnostic equipment, a Global Diagnostic System for GM, an ISTA for BMW, an Xentry for Mercedes, a GDS for Hyundai Kia. These tools cost between $2,000 and $15,000 per manufacturer, and they require manufacturer subscriptions that run hundreds to thousands of dollars annually. The second is the security gateway access. Manufacturers have added secured CAN bus gateways that require online authentication for each programming session. Without the authentication, the ECU stays locked. The third is the software image itself, which the manufacturer distributes through a controlled channel. When the security handshake fails partway through a flash, and it does fail sometimes, even at the dealer, the ECU bricks. A bricked ECU is a paperweight. Replacement is the only recovery path. A new ECU on a modern vehicle runs between $800 and $2,300, depending on the platform. Some manufacturers will not sell a bare ECU at all. They only sell a pre-programmed module keyed to a specific VIN, with surrender of the old ECU required. DIY ECU programming, on anything from about 2015 onward, carries a brick risk somewhere around 1 in 10 on a typical attempt with hobbyist tools. I have done this myself once, on the customer truck I mentioned at the start, 2014 Silverado, transmission software update. It worked. I would not do it again. The shop bill for a flash on a known platform, say a transmission software update on a Ford Fusion, runs about $100 to $200 at the dealer. That charge covers the dealer's licensing of the GDS, the technician's certification, the security handshake, and the warranty on the result. The DIY alternative, if it goes wrong, is a brick on a car you may not be able to drive to the dealer without a tow. Read what the OEM actually says, not what the forum claims. Every major manufacturer publishes service information on what is dealer only. Case 7. High voltage battery work on hybrids and EVs.
This is the case where DIY does not just cost more, it can kill you. The battery pack on a Tesla Model 3 operates at about 350 volts direct current. The Chevy Bolt operates at about 360 volts DC. The Toyota Prius hybrid pack runs at about 280 volts DC. Any voltage above about 60 volts DC applied across a person's chest has a high probability of causing cardiac arrest within about 2 seconds. What makes this worse on EVs is that the battery pack itself is alive even when the car is off. The high-voltage system is isolated from the chassis by relays and contactors, but a damaged pack, for example, after a collision or after improper handling during service, can short the isolation. If you reach into the wrong place, you become the path to ground. The OEM training for working on these packs runs 40 to 80 hours.
It covers personal protective equipment, Class 0 high-voltage gloves rated for 1000 volts AC, arc-rated face shields, insulated tools. It covers shutdown procedures, the orange high-voltage cap that must be pulled and stored before any pack work, the wait time for the pack capacitors to bleed down, the verification with a high-voltage probe. None of this is plausible in a home garage. A Tesla battery module swap, when done at an authorized service center, runs between $5,000 and $15,000 depending on the model and the failure mode. The total cost includes the battery module itself, the isolation tests, the BMS reprogramming, and the warranty on the new module. The DIY alternative is statistically dangerous. Working at 350 volts DC without certified PPE has resulted in fatalities. Not many, but more than 0, every year since EVs became common. There are 7 cases of mechanic right, and this one is the most absolute.
The math is not about cost. The math is about 350 volts and your heart. The mechanic with Class 0 gloves and the orange high-voltage cap on the bench is the only viable path. 7 cases, timing chain replacement. R-1234YF air conditioning service. CVT internal work. 4-wheel alignment with calibrated optical metrology. Supplemental restraint system service. Engine control unit programming with manufacturer-secured gateway. High-voltage battery work, above 60 volts DC. In each one, the shop bill that looks high is the discount. DIY alternative, even when it goes well, costs more. When it goes wrong, the costs scale into thousands. In 2 of these, SRS and HV battery, the costs scale into a hospital visit. Or worse. The argument is not that mechanics are right about everything. Mechanics are wrong about a lot. Most of this channel is about exactly that. The argument is narrower. Control is not doing every repair.
Control is knowing which 7 you do not touch, and what each one of those 7 actually requires before you walk into the shop. When you know that, when somebody quotes you $480 for an AC service or $1,400 for a CVT rebuild, you can read the bill instead of just trusting it or just rejecting it. You can see what they are charging for. Either it lines up with what this video described, or it does not. The boundary is yours to draw, but you have to know where the boundary actually is before you draw it. Where is yours right now? If you walked into a shop tomorrow with one of these 7 repairs in front of you, would you know the difference between an honest quote and a padded one? If somebody asked what the channel is for, the answer is simple. Owners who can tell the difference between a good mechanic and a bad one, between a real repair and an upsell, between equipment cost and labor margin, between their own competence and the boundary of it. Those are the owners who get to 250,000 miles on the original engine. Those are the owners who do not get sold things they do not need. Those are the owners who, when they do pay the shop, pay for what is actually worth paying for. What is the line for you? Where did you find out the hard way that the boundary was closer than it looked?